Okay, do you see my screen, people? Do you see my screen? You don't? Do you see my screen?
Yes.
Yes.
Say yes.
Yes.
Thank you. Okay, so let's continue again. Late binding and early binding is defined this way. Let me take this out. So this is working fine. Do I have enough space? Do I have enough space? Yeah, it's kind of okay. Yeah. So let's give more examples about this. Again, usually this shape hierarchy is given as a first example, but in real life there is no such shape hierarchy. Nobody uses this stuff. Just it is simple, but this is real. These are real. Okay. If you have an operating system and if you are accepting applications like this, they use this kind of a structure. If you are developing graphical user interfaces, with the graphical user interfaces, there is a window-based class, and you derive all of your other classes from that window-based class, frame-based class, and you continue writing your code that way. So polymorphism is used a lot in real life in these kind of professional libraries, in these kind of popular libraries. Okay. But again, nobody uses a shape class like that. This is a very simple example just to show you what's happening. Okay, so let's go back to the book slides. Again, the book says that, okay, it talks about rectangles, circles, and ovals. I already talked about it, so I'm going to skip this one. I am going to steal some other stuff from another C++ book, and I think I already opened it. Maybe did I open it? Lecture, what is it there? No, I think it is not there now. Let me open this with the draw board. Okay, so this is from Detail and Detail. I will put this as this slide set to the Teams page. You know the example actually. Let me show you what we are going to do. We are going to do where is it? Where is it? Let me show you. I have the class hierarchy somewhere if I can find it. Can I do this? Yeah. Here is my class hierarchy. Employee, class employee is going to be our base class, but it's going to be abstract base class. Okay. And hourly employee, commission employee, and salaried employee are derived from the base class employee, and base plus commission employee derived from commission employee. Okay, so hourly employee earns by hour. Salaried employee earns by the week. Commission employee earns by the sales he or she makes. Okay, and base plus commission employee, I pay them $50 a week, plus on top of it I give them some commission based on how much they sell. Okay, so this is the hierarchy, and our class employee has two functions. One is earnings, how much money it is making. The other one is print. Okay, the earnings for the employee is pure virtual. Why? Because I don't know what to return for the earnings. Okay, but print function is something different. Print function says that I can print my name and social security number on the screen. It is as simple as this. Okay. So this is an abstract class. All the rest are concrete classes. Salaried employee is a is a concrete class, and for the earnings I return just my weekly salary. For the print I print this. Okay. First name, last name, social security number, and weekly salary. So it looks like I am going to borrow this print function from the base class, and I am going to add this weekly salary, and etc. The rest of them, hourly employee wins this much, earns this much, and prints it. Commission employee this, and base plus commission this. So let's look at the code. Okay. So what did I say about object-oriented programming? Without writing a single line of code, I told you what the main structure of the software system will look like, right? So it's going to be more than 1,000 lines of code, yet I did not write a single line of code to tell you what's going on here, right? Okay. So if I give you as an assignment, as a homework assignment to you right now, you can do this in a few hours maybe. Okay. And the nice thing is, you can write this in Java or C++ or C#, whatever object-oriented programming language you like. Okay, so that's the beauty of object-oriented programming. You talk about your software system without writing code. Okay, so it is more closer to our thinking. With the C programming language, I mean, yes, you could apply these kind of rules, but it is not that customary. Okay, it's kind of with the C you have to define each function and that kind of stuff, and this is already known. If you know the inheritance, if you know the polymorphism, you got the idea. You know what's going on with this picture. So, designing a software system, complicated software system becomes easier. Understanding somebody else's software system becomes easier. Maintaining this becomes easier too. That's why we are trying to learn object-oriented programming languages. That's why we are trying to do object-oriented design. Okay, object-oriented design. Okay, let's look at the code again. Employee. Remember employee, it is this. So this is slide number 65. We will come back to this often. So 65. Don't forget that one. Okay, employee, let's look at the private data first. First name, last name, social security number, that's good. And constructor will take first name, last name, social security number. Okay, set first name, get first name, set last setters and getters. Nice constants here. And for the constructor, I don't have explicit because this will take more than one parameter. Okay, it is setter and getter for 3 of them. Now I have the earnings and print. Earnings is going to be pure virtual. That's why this class of employee is abstract class. Okay, and print is going to be virtual too. That means what? I will make the decisions for the earnings function calls and the print function calls, okay, during the runtime, not during the compile time. Okay, this one, all these 6 will be decided during the compile time, but these 2 will be decided during the runtime. So they will be a little bit slow to execute, a little bit slow because I need to make some kind of a lookup first. But after that, this is just a regular function running. Okay, so good. 2 of them are virtual, the rest of them are not. And these are my private data members. So implement it. This one doesn't have a namespace. It should have a namespace, but it doesn't have a namespace yet. Okay. Employees constructor, use the nice member initializer section. No problem. Did this have any header? Yeah, it has the guards, right? Yeah, it has the guards. That's good. Okay. So I included the employee age, constructor, setter, getter. Now let's look at this one. Get social security, print. Remember the one that's about the earnings? I didn't write anything because there is no implementation for it. This print function is virtual. Okay, it is virtual but not pure virtual, so I am implementing it. I don't say while I'm implementing it, I don't say that this function is a virtual. It is sufficient to say virtual in the class definition. So all I do is get first name, get last name, print them on the screen, and social security number. That's it. Okay, good. Simple class. The only thing is these two lines, two virtuals. One of them is a pure virtual. Good. And let's move on to next class, which is a salaried employee. Salaried employee is an employee. That's for sure. Okay. But on top of it, this employee knows what this employee earns. Okay, it knows how to implement his earnings because this guy has weekly salary. So my constructor name, last name, social security number, weekly salary, and setter getter for the weekly salary. Of course, I am going to override these two of them. I keep using these terms. Let's look at them. Overload, we have been using it since the beginning of the semester. It means that simply using more than one function with the same name but different signatures. Okay, it was something useful. Then we talk about redefinition. Redefine. We redefine a function that is defined in my base class, okay, in the derived class. I have a function in my base class f. I am redefining it for my derived class that's called redefinition. So how is this different from redefinition? This is redefinition, right, especially for the print. I had a print function in my base class. I am redefining it. The thing is, it is a little bit different. Why? Because the meaning of the print will be determined during the runtime. Okay, so print is a little bit different from the regular functions. So instead of saying this is redefinition, we are going to say that we are going to override our base class definition of print. Okay, so redefinition and override are close to each other. Okay, they are related. Overloading is completely different. And in fact, some people use these two terms interchangeably. Okay, sometimes they use redefinition, sometimes overriding. But the correct terminology is redefinition is for non-virtual functions, override is for virtual functions. That's why this guy says functions will be overridden, okay, or defined for the first time. Good. So, earnings and print. Let's look at the implementation. Includes salaried employee age. Okay, nicely send the first class and SSN to the base classes constructor and set my weekly salary. No problems. And then set weekly salary is doing this. If it is less than 0, make it 0, otherwise it is salary. Getter for that one. How about these two virtual functions? Earnings, just return my get weekly salary. Nicely calls the public interface without accessing the private data. Nice. Okay, how about this print? It is good, right? It says salaried employee. I'm printing a salaried employee. It calls the employee's print. So this is not recursion. Okay. I am overriding salaried employees. I am implementing salaried employees print. I am overriding my base classes print, but I need the base classes print too. I am calling the base classes print so that it prints the already defined stuff for the base class, and then I am printing the weekly salary. Okay, so why am I doing this? I am doing this because I don't want to print the employee's name, last name, and social security number again and again for all the classes. This is already printed. Okay? We did this before, now we are doing this again. Where did we do this? Remember we call the base classes assignment operator, we call the base classes other stuff when we are doing the inheritance. And in fact, this is almost the same as calling the base classes constructor here, right? We get from the base class, we get help from the base class. And we get help from the base class here too. Good? So that's it. That's for the whole class. Salary the employee, very simple class. It is simple because I push most of the complications to employee class. And that's nice. That's the idea of inheritance. Okay, let's move on. Let's talk about, did I miss anything? Yeah. Hourly employee, okay, salaried employee is a concrete class. I am going to write another concrete class, hourly employee. It will inherit from employee, and we are going to overwrite stuff again. Hourly employee, public employee.
Sir,
Yes.
can we define setter and getter function in a base class and make this virtual like earning and print?
What are you going to say? That's a good question. So you are saying that, let's go to 65. Let's go to 65. You are saying that you are going to add setter and getter for what?
For employee class.
Setter and getter for what data member?
Okay. Get the
set hour.
yes.
Should we do this? If I let set hour as a pure virtual function, well, you could do that because you're not going to implement it. But what would happen to your hierarchy? Commission employee has to inherit the set hour, and it doesn't know how to implement set hour, right? Okay, so set hour is too specific for employee. Employee shouldn't know anything about hours. Like this commission employee will have a commission amount, 5%, 10%. It is meaningful for commission employee, but it's not meaningful for hourly employee. Okay? So the thing is that put everything that needs to be done, put inside the employee, but don't try to put too many stuff because that doesn't make any sense for example, the commission employee base plus commission employee. Okay?
Okay.
Okay, so it's a nice thing to, this is a class where you put all the common things about this employee hierarchy. Put all the common things. For example, the print is a common thing, earnings is a common thing. Other than that, I don't see anything other. Because if you don't put the common things inside this employee, then you will have to repeat that in each of the classes. That's a bad thing, okay? But I cannot do anything better than print and earnings.
Can I ask?
Sure.
Can we write virtual function to print operator overloading functions?
Well, yeah, you could say that an overloaded operator, for example, an assignment operator is a virtual. Yes, you could do that, but usually we try to avoid that because that assignment operator, remember, assignment operator is not inherited the way that so it makes it kind of confusing. How about the for example, the plus operator virtual? Yes, it could happen. You could write it, but again, it's going to be kind of confusing because I didn't tell you all the things that needs to be known about how to call the virtual functions. Virtual functions sometimes behave like non-virtual functions if you don't call them right, okay? And we are going to talk about it when we call the virtual functions, when we talk about the virtual functions, okay? Good. So let's go back to slide number, what was the slide? 80? 75? Okay, hourly employee is this. We are talking about hourly employee. Hourly employee is this, and again, it has wage and hours. Wage is how much money I am making for each hour. Hours is how many hours I worked for this week. Okay. And of course, I'm going to write setters and getters for both of them. And again, like I did before, my earnings and print both virtual functions, and I will override them. Constructor is name, last name, social security number, wage, and hours. So I'm going to send these three to the base class. I will set it using the set wage. I will set this using the set hours. Let's go there. Okay. Implementation, like I said before. Base class constructor and use the setters. Nicely written code. Check all the errors. Okay. Check all the errors. Okay. So what does this say? It says that a person cannot work more than 168 hours a week. That's illegal. Okay. And a person cannot work less than 0 hours, of course. If it happens that case, it is 0, otherwise it's hours work. Okay, get this way. Okay, how about this earnings? Earnings says this much. It says if I work less than 40 hours a week, I just multiply it with wage times hours using the public interface. Otherwise, I do this. For the 40 hours, I pay the regular wage. For the rest of the 40 hours, I pay extra, okay? Because I am doing overtime. Ekstra mesaiye kalıyordum. Okay? And then I have my print function. Again, I am calling the base class's print function and get wage and get hours. Remember this virtual. And what, okay, so earnings is virtual and this one is virtual. Good, okay, let's continue. Let's continue now. We are going to write it for the commission employee. Remember, the commission employee says that I am going to earn money by this calculation. How much sale I made, gross sales, and it depends on my commission rate. So if I sold $10,000 worth of goods, and if my commission is 10%, then I'm going to earn $1,000. Okay. Good. So implementation is again is going to be simple base class call and setter and getter for commission rate and the gross sales, and earnings is this: get commission rate times get gross sales. And print is very similar to print of the hourly worker. And then again, this is continuing. It is going on and on, but it's becoming boring. There is one interesting class: base plus commission employee. Remember this hierarchy. 65. Okay, base plus commission employee derives from commission employee. Okay. So let's go to this one. Base plus commission employee is this. Say that I am a commission employee, which is in turn an employee, but I'm a commission employee. So if I am a commission employee, I need the gross sales and the commission rate, right? Commission rate, plus I need a base salary too. So these three, 1, 2, 3, will go to the employees constructor. These two will go to the commission employees constructor. This one is mine. So I am going to add one more thing, base salary, these two. So let's look at the constructor actually. So constructor is nice. It says that I am going to send 1, 2, 3, 4, 5 things to commission employee, which in turn calls the employees constructor with these three stuff, right? So I don't care commission employee derives from employee or some other place, or It's just a regular class. I don't care. All I know is that I derive from commission employee. I need to call the commission employees constructor like that. And then I have my setter for the base salary. Okay? So base salary is very similar to, remember the salaried employee? It's very similar to salaried employee, and that's what we are doing here. Base plus commission employee. And let's look at this one. My earnings is same as the commission employee's earnings plus I have some base salary. Okay? So this time for the earnings, I am overriding the earnings of the commission employees class, and I'm adding the get base salary. Okay? And my print is doing the same thing. Commission employees print and doing it that way. So always communicate with just your parent, not your grandfather or other ancestors of yours. Just deal with your parent. That's it. So we have implemented all the classes, including the base class, abstract class. Now we have implemented 1, 2, 3, 4 classes right now, right? So let's write some driver code. Let's write some code that uses all of them at the same time. By the way, as I said before, this is not compilable. Why? Because the earnings is pure virtual. So employee is a what? Employee is a abstract class. All the rest is not an abstract. All the rest are compilable. Okay, I don't remember what I did here, but yeah, okay. It's good, right? Let's say if we have a function, its name is print st, it's a global function, okay, and it takes an employee pointer, okay. With this function, I can do this kind of stuff, okay. EP get name, EP print, and EP earnings, and EP get hours, okay. All of them are okay. This one is not okay. Why? Because employee doesn't have a function named get hours. This is even valid if I even do this, okay? I have an employee pointer, hourly employee, okay? And can I do this? Employee gets the address of hourly employee.
You can.
Yes, I can. Why? Because hourly employee is an employee, and I can assign the pointers of hourly employee objects to employee pointers. So I can do that. And I'm calling this print st, okay? When I call this print st, okay, print st like that, I know that EP points to an hourly employee. Still, I cannot call get hours. Can somebody explain this to me? Why cannot do that?
Get hours is not. Get hours doesn't.
Who's talking? Are you talking? Yeah.
Get hours doesn't belong to EP.
But the object that I send the print st is an hourly employee.
Now, this object doesn't have a function get hours after the assignment.
Well, I didn't change but let's look at the picture actually. Picture is something like that. I made an hourly employee, HE. Inside the hourly employee, what do I have? I have the name, I have SSN, and I have the hours, and I have the wage, right? I have 4 or 5 things. What is EP? EP is a pointer. It points to this object, right? So I am sending this EP to this print st. So this EP actually here is pointing to this object, And inside that object there is hours field, right? So how come this get hours doesn't work?
I think because compiler doesn't know yet the function get hours exists.
Yeah, exactly. I mean, think about the compiler. Compiler says that I am compiling this code. I don't know what kind of pointers I am going to get. I can get the employee pointers, hourly employee pointers, commission employee pointers, and etc. Okay? All the compiler knows that employee has get name, print, and earnings. Compiler doesn't know that the object that is going to get will get is have a hours field in it. So this is a bad thing. Let's look at this code, okay? When I say there is a commission employee, I can make this assignment too, right? This assignment is correct. No problem. This commission employee. If I send this commission employee EP to this print SD, does the commission employee have any hours field in it? No, right? So this would have been in trouble. That's why this is not acceptable. Remember, this code is compiled with the employee header only. Okay? It doesn't need anything other than the employee header to compile this code. Okay? It doesn't need anything other than the employee header. That's why in the employee header, I don't see anything about get hours. It's kind of confusing. It's kind of, how come I have it, etc., that kind of stuff. But those are the rules. Those are how the compilers work. Okay? Compiler only sees that this is an employee pointer, and inside the employee header, I have three functions: get name, print earnings, get set name, and etc. But those are not relevant, right? I don't see anything like get hours or get commission rate and etc. So this will not compile. This will not compile. Okay, so don't do that. If you want this to be compiled, then add get hours to the employee class. But in that case, your question, it doesn't make sense to adding get hours to the employee class because not all the employees will have that kind of functions, because get hours doesn't make sense for the commission employee. Okay. Good. By the way, remember there's virtual functions, print virtual function, and the earnings virtual function. Virtual functions, they are treated as virtual functions only if you call them through the base class's pointer or through the base class's reference. If you call them directly with an object name, they don't become like, they are not called like virtual functions. Okay? So in order to use the virtual function features, you need to call these functions through the base classes pointers or base classes references like this. Okay? Base classes references like that. Otherwise virtual functions, they behave like regular functions. Okay? They behave like regular functions. For example, if I do this, just get rid of this one. Okay? So what is EP is an employee. Well, this is not going to be possible because you cannot have an EP object. But let's ignore that fact. But if you do that, when you say ep.print, this will call whatever it is. This will call the print function of the base class. This polymorphism will not happen with the object names. That's why, okay, to use the polymorphism, you have to use the base classes pointers or base classes references, either this one or that one. Yes?
What if we do EEP pointers shape and
where are you going to write? You mean here?
Scope resolutions get ours. Is it still implementation? But
so EP pointer, then what?
Hourly employer.
Hourly employee,
Scope resolution.
employee, and get name, etc. Right? Is that what you're saying?
Yes.
Get hours.
Get hours.
Yeah. Well, that's a good question. What do you think? I'm asking this question back to you.
I think, is it compilable?
What do you think?
If hourly employee is
Where did you get this idea of putting it in here? I mean, so once we did that print, right? We used the employees print, call employees print. That's where you're getting the idea, right? I mean, your idea is from here. You are saying that if I can do this, base plus, yeah. Let's look at the implementation. Implementation is here. Okay, so you are getting it from here. Calling the commission employees print. But the thing is that commission employee is a parent of base plus commission employee. Okay? Commission employee is a parent of base plus commission employee. So we are saying that I am using my parent's print function. Here, hourly employee is not parent of employee. Right? So this doesn't make any sense. So compiler error. No, it doesn't work. So he said that, I know what he's thinking. He said that I know that EP points to a hourly employee object. I know that, right? Because I said it. So I'm going to force the compiler to make this call hourly employee, get hours. So idea is nice, but it is not implemented that way. And I will show you how to do that actually. If I know that this EP points to an hourly employee, then I will figure that out, and I will do the get hours calling in a few minutes, maybe on Monday, and that will be the end of this chapter, polymorphism. Okay, so it will be called. Okay, so what did we say? What did we say about this hierarchy? Okay, I'm going to tell you one English sentence, and you tell me it's true or not. Okay. All the square objects are rectangles. Is this correct? Yes. All the rectangles, none of the rectangles are not squares. It's not correct because some of the rectangles are squares, right? So this is a relationship kind of tells you that. So some of the shapes are squares, some of the shapes are rectangles, but all the rectangles are shapes. Okay, so since there is an is a relationship, I can accept this. I can take a shape pointer. Okay, I can take a shape pointer, and I can get an assignment to this one square. Okay, let's say SQ is a square object. Okay, this will work. This will work for the shape pointer SP. Guess this value. This will work all the time. But if I try to do the opposite, a square pointer, and I'm trying to assign a square pointer a shape pointer. Well, the compiler will not let you do that, but you know that your shape pointer points to a square object. If you know that, definitely, maybe we can force it, maybe using the typecasting. I am telling you, okay, make this as a assignment. You can force your compiler to do the assignment. Or there is a way of saying that what kind of object am I looking at with the shape pointer? Okay, the compiler will tell you that, and we are going to use that information in a few minutes. Okay, let's go to detail again. Let's write some code. Here are my code. Okay, so virtual via pointer, virtual via reference. Okay, and why did I put a cross mark here, F employee E? You cannot write such a function. A function that takes an employee object. It's not possible. Why? I don't understand what you are saying is, but I think you are saying it's correct. Because there is no such thing as an employee object, right? Because employee is an abstract class. Nobody can make objects of employee. So writing such a function prototype is not possible. These both are possible, okay? I am not going to make an employee object of class employee. I am going to make a object of one of the hierarchies, right? Okay, and then I will send their pointers to them, hourly employee pointer or hourly employee reference. Okay, so these both of them are possible. These are main function. Okay, some formatting stuff. A salaried employee, hourly employee, commission employee, and base class commission employee, 4 of them. I have 4 classes. And I call the salaried employee.print. Line 43, no polymorphism going on here. This is early binding, static binding. Sometimes they call it static binding. Okay? Although the function print is a virtual function, okay, since I am not calling this print through the base class's pointer or reference, this print is definitely the print of the salaried employee. This print is definitely print of the hourly employee, commission employee, and base plus commission employee. The compiler knows it during the compilation time. None of them are polymorphic calls. None of them are decided during the runtime. They are all early binding stuff. They are all static binding stuff. Okay? So virtual function doesn't mean that it is always slow, it is always late binding. It depends how you call it. It depends how you call it. So that's why I am going to use these 2 functions, because they are using the base classes pointer and reference. Okay? Now I can do this, right? This is nice. I have an employee pointer vector of size 4, and inside this employee vector I will, how am I doing with my, I think this is good enough. I am going to put each of the pointers of those objects inside this vector, and it will work because there is a relationship between salaried employee and employee, right? All of them are possible, and compiler will gladly say yes. Okay, this is no problem, and this is what I am doing. Okay. Okay, this is just, I am calling this employee virtual via pointer function with each of them as an employee pointer, and this, whatever this function is, what is this function? This function, okay, virtual via pointer, virtual via reference, okay, will just work, and let me see the definition of it. Virtual via pointer, it just calls the print function and the earnings function, okay, calls the print function and the earnings function in a polymorphic way, in a late binding way. So these line 85 and 86 are not going to be decided during the compile time, but they will be decided during the runtime, okay, during the runtime. So I am calling the, remember, I don't know what kind of object I am getting, okay. I know it is going to be some of the derived classes of the employee class, either hourly or commission or whatever, okay. So it will be decided during the runtime which object I get, and its print function will be called, and its earning function will be called. If I have such a thing, in this, for example, cout base class ptr and get name, this is definitely not polymorphic call or the late binding call. Why? Because, why not? This one is a polymorphic call. This one is a late binding example. But this one is not. Why not?
GetName is not a virtual function.
Exactly. GetName is not a virtual function. Print and earnings are virtual functions, and they are called through the use of the base classes pointer. But this one is not a virtual function. So get name is, so whose get name will be called? The employee's get name will be called. Well, you might say that there are no get names anyway, but that doesn't matter. It is, even if you had it, base classes get name will be called. Okay? So this is